Definitions. I'm a little unorthodox when it comes to notes. You can tell already, right? I'm just regular versus irregular polygons. So that's the first. I want you to know the difference. So the check mark for a regular, or the two tests you need to perform, would be to check if all sides are congruent. And the second, all angles are congruent as well. And for irregular, we will say that some sides may be congruent, and that some angles may be congruent. In other words, not all are, but some could be. That's not good enough to fit into the regular category, right? You have to meet the criteria. So I'll give you some examples that you already know, right? So a triangle that has all sides the same would be called an equilateral triangle, right? So it has all angles, all sides the same. Okay. What about an isosceles? Would that meet the criteria? No, it wouldn't, right? So you have two sides and two angles, but there's this one side that's different and the one angle that's different, right? So this is a regular polygon, irregular polygon. Polygon is basically any shape that is closed. Okay, and I will say here fails both tests, right? So what I do, just for note-taking purposes, I kind of go check and check on this one, right? It does fulfill both requirements. This triangle is not meeting either one of those requirements to fit the regular bill. Okay, then we have quadrilaterals, which are four-sided. You have your square, and all four angles are the same. All four sides are the same. That would definitely be a regular polygon. So you go check and check. What about its cousin, the rectangle? Cousin. Does it meet all angles being the same? It actually does. Yeah, it does. It has one check mark, but you need both check marks to make it into the regular category. The side lengths are different, right? So sides is a fail and the angles is a pass, right? So rectangle fails all sides congruent test. And the list goes on. We could do pentagon, hexagon, so forth. So I'll just briefly give you a oh, what happened there? If you just look up on the screen for a bit, I'll just show you. So take any polygon you'd like. For example, I'm just gonna go five-sided, right? That would be a regular polygon. An irregular, right, would be something like this. It still has 5 sides, right? But it's not, you can clearly tell that this one has all sides the same. And what can you conclude about the interior angles? If all sides are the same, all angles will also be the same, okay? You cannot say that about this one. It's very obvious, right? But this is still an interesting fact, is that the sum of interior angles of both of these is going to be 180 degrees, right? The sum of interior angles for both of these shapes, the four-sided shapes, is going to be 360. So that doesn't change. What changes is the interior angles, right? May change after a while. Okay. So polygon is a closed shape uh, with the same number of sides and angles. So a pentagon will have 5 sides, it will have 5 angles, right? A triangle has 3 sides, 3 angles, so no news there. The other difference you need to know is convex versus concave. And I'll just give you a diagram for each one of them. That would be a convex. It's a hexagon. It's not a regular, obviously, but it is there. And then you could have this angle I want to focus in. It caves in. That's just me trying to help you out. Like it caves in. It's like it goes into itself. And so you have a reflex angle. Reflex angles, right, are bigger than 180. So that's the main difference between concave and convex, right? No reflex angles. I.e. less than 180. %99 of our scenarios will be convex. I'm contemplating if I'm going to make this work space-wise. Let's try that. All polygons have interior and exterior angles. that are supplementary. Very important. Interior and exterior angles are supplementary. I'm going to go onto the next page, so I'm just waiting. Right, so take a triangle. Let's just make an equilateral triangle. Start with a triangle. And let's follow the base here, okay? So you're traveling along the base, and you will extend. As soon as you get to the corner, you make a dashed line just to extend it like that. That is your exterior angle right here. Okay, we usually just call it E, capital E, right? And follow along now this side. You're gonna travel until you get to the vertex, right? And then you just keep traveling on a straight line, right? You continue the same path as the side, just make it dashed as soon as you leave the shape. And so that's your exterior angle there. And then you do the same thing. You travel down the third side. And this is an exterior angle there as well. And if you have a different color, if you have a pen, a red pen or something, blue pen, if you're using pencil so far, just do one of these. Like finish that circle, and inside we have interior. That's the interior angle there. You go to the top, interior there, interior there. What do you, so I just told you that they're supplementary, right? Can you tell that they would be supplementary? The I and the E, right? No matter which corner you go to, they would add up to 180, right? Even if you look at these two, they're along a straight line, right? So I plus E is always 180 degrees. That's basically summarizing the statement I just gave you. If you know one of them, you can find the other one. No problem. It's just like we've been doing so far. Okay? Number of sides equals the number of interior angles. Somebody help with the door there. Number of exterior angles. So 3 sides for a triangle, right? 3 sides, 3 interior angles, 3 exterior angles, no exception. So it doesn't matter how many sides the shape would have, they would all line up and they would all match. And here's another cool fact here. Sum of exterior angles is always equal to 360 degrees. Note this. And I will qualify this by saying regardless of the number of sides regardless if regular or irregular. So it's always true. The exterior angles of any polygon is always 360. So can you imagine a 50-sided polygon that has 50 sides, and yet if you added up those 50 exterior angles, it would always add up to 360. It's a very useful property, and you'll see why later on. All right, let's talk about formulas. Okay. N represents the number of sides. Just remember that. So S of n, so the function, this is a function technically. If you wanted to know the sum of all interior angles, you would go n minus 2 times 180 degrees. Okay, so we say that this is sum of interior angles. Okay, the next one, Cn is 360 degrees divided by n. Oh, sorry. Can I back up? Otherwise it doesn't flow nicely. This one will be 1, but change the C to an I, capital I, and we have to change the top. The 360 is gone. Yikes, sorry. N minus 2 times 180. Watch, it looks very much like the one I just gave you, except for this one is being divided by the number of sides. Okay? This would be the measure of each interior angle. There's going to be a but after this, but anyways. Then we have C is 360 divided by n. This is the measure of each central angle. I'm going to leave a bit more space. E is 360 divided by n. Measure of each exterior angle. And the last one, D. This one is n times n minus 3 divided by 2. This is the number of diagonals that can be drawn. So you should be psyched about polygons. Do you see that? That's not how you spell it, I know, but psyched. Psyched about it. Sized. So these formulas definitely make sure you get them onto your study sheet. Ice in the middle here. This is only going to work for you if it's a regular polygon. Regular polys only. So that means that this one always works, and the last one always works as well. So let's try an example here. Label the interior, the central, and the exterior angle for the following. So let's try to draw a pentagon here. So you make that little hat. You go in an angle like this, and you close it. Okay, so we know that when you count, right, you make a little mark here, 1, 2, 3, 4, 5, so n is equal to 5. That's always very important. You need to know the number of sides you have. And I'm going to use a different color here. There are 1, 2, 3, 4, 5 interior angles, but you're just going to label one of them. So it's the angle that is made between the sides. Okay, so that'd be called our eye. Where would the exterior angle be? If you pick any side on this thing, any side, travel along it, and then as soon as you get to the end of that side, you just keep going. A couple of, just make it dashed. And so in this case, that would be one exterior angle here. I like to have them side by side because then you can tell that they're supplementary. You don't have to. Okay. Next, we have our central angle. So we did the I and E. So the central angle, it says that the name says it all. You got to find a center and then travel to each corner, consecutive corner that is. So we go to this corner and to another corner. So you have a slice there, right? And that is called the central. This angle formed is called the central angle. How many central angles do you think there will be? 5 sides, 5 central angles. I just labeled one because it's too busy if I do all 5. 5 interior, 5 exterior. Okay. I think we're good there. So let's calculate. Okay. Calculate for that particular one. We're going to find the sum of interior angles, just the one interior angle, a central, an exterior, and the number of diagonals that can be drawn in it. So for sum of a 5-sided, so you're just saying you're trying to find a sum of a 5-sided polygon. So that would be, just insert 5 for n, subtract 2 from it, you multiply by 180. I don't know why I put that line there. Don't worry about that. So that is 3 times 180. And that would be 540 degrees. So the sum of all the 5 angles in a pentagon, if you add them up, it's going to be 540 degrees. Okay. The interior angle, it would just really be 540 divided by 5, correct? But we're going to use the formula. 5 minus 2, that's n minus 2, right, times 180, divided by 5. So that ends up being 540 divided by 5, which is 108 degrees. The central angle of a 5-sided shape is 360 degrees. Why is it 360 for a central? Because it's 360 at the center, right? If you go all around, it's 360. So if you splice it into the number of sides, then you know how much of that 360 goes towards each central angle. So it's 360 divided by 5, which is 72 degrees. And the exterior happens to be the same, but I will throw a little extra in here. It's 360 divided by 5, all right, 72. Or what else do we know about the interior and the exterior? They're supplementary. So I could also say, hey, if I just go 180 minus I, oh boy, it's going to be very cramped, minus 72, sorry, 108, right? That is 72. So 2 ways of figuring out the same information. Sometimes it's better to do it this way. Sometimes it's easier to do it that way. And last but not least, the number of diagonals. The formula is n times n minus 3 over 2. That's 5 times 2 divided by 2. That'll be 10 divided by 2, which is 5. 5 diagonals. I will just show you on my smart notebook here. I used to have a smart board and I miss it, but anyways. So if you go from here to there, right, those will be 2 diagonals right there. It's a little bit overkill, right? But anyways. And then if you go from this corner to that corner, that's 1, 2, right? And then you pick another color, and the only one that you need to connect still is from here to here. Right? So there's 5 diagonals. You see them? Count the colors, right? There's 5. We just calculated that. And it changes the more you have, right? Like if I have a no, wrong one. If I have a 6-sided, let's add another page here. Right, 6-sided. If I were to do the same thing again, let's go red first. So 1, 2, 3. Oh boy, I'm gonna get this wrong. I know, I see that already. So here goes that. Different color. Are you counting? I'm missing one more. I'm not seeing it, sorry. From here to this one. Okay, got it, got it. I gotta change the color. I'm glad you're playing along. Okay, there. How many transversals can you count? 2 green, right? And I have 1, 2, 3 reds. I have 2 yellows. I have one. What color is this? Teal or? And then the 1 purple. So if we count, right, 4, 7, 9, right? Is that true? Let's use our formula real quick. You don't have to do that in your notes because it's gonna mess everything up, right? But if n is equal to 6, then diagonals, I hope this works. Otherwise, I'm in trouble. So 6 times 3 is 18, divided by 2, 9. Phew, right? So that's what that formula does for you. Okay, I want one more example at least. I can tell you're loving this unit. Sorry, okay, here. Example, given a regular 14-sided polygon, calculate. Make sure I write this down. A, the interior angle. B, the exterior angle. C, the central angle. I need you to show me 2 ways of doing this. I need to be able to. And I need you to figure out the sum of exterior angles. So write that down first. That's number 1. Leaving a couple lines there. So first and foremost, you need to establish that n is equal to 14. Thank you very much, right? The question says it already. Don't need to remember the name. I will give you the prefixes and the number of sides as well, because you need to know what a decagon is, like how many sides. Not today. So 14 sides. So for A, I will just use that formula, right? Just need to have that if you plug in 14, it's 14 minus 2 times 180 divided by 14. And that ends up being 154.29 degrees. The more, would you agree with this statement? The more sides it has, the bigger the interior angle will get? Sure, maybe, right? Like, because the more sides you have, the more it becomes a circle ultimately. If you go into infinity, it would start looking like a circle. So you're getting closer and closer to 180, okay? And then B, the exterior angle. Exterior angle of a 14-sided shape would just be 360 divided by 14. And that is 25.71, or exterior angle is 180 minus the one you just found. And by the way, you could go the other way as well. If I gave you the exterior angle, you should be able to come up with the interior angle by just using this property here. Oh, sorry, this was supposed to be here. Oops. The central angle, there's only one way of doing that. Central of 14 is also 360 divided by 14, and that is 25.71 degrees. This one is really hard. What's the sum? Let's see if you were awake. What's the sum of all exterior angles? 360? Oh my goodness, you are awake while I'm talking. Okay, good. It's always 360. It doesn't matter how many sides. It doesn't matter if it's regular, irregular. It's always 360. So that's a trick, bit of a trick question. Hold on. This one gets a bit trickier, right? So there's these ones, you just plug in and go. The sum of interior, I will sum angles of a polygon is 3060 degrees. Determine the number of sides. And notice that this question is saying that the sum is this, right? So they're essentially saying that the sum of an n-sided polygon, we don't know what n is, would be 3060 degrees. So what you do, you don't want this there now. You're going to replace this left side with the actual formula, right? So it's saying n minus 2 times 180, that is equal to 3060. Oh, don't forget to distribute here, folks, right? IPR, right? You got to distribute amongst both of those. So it's 180 times n, and then it's minus 2 times 180, which is 360 degrees. And that's 3060 degrees. I will bring the number over to the other side. So I end up with 180n is equal to 3060 plus 360. So it's 180n is equal to 3,420. You cannot get negatives, folks. If you get negatives, go back. You made a mistake. Okay? But don't just get rid of the negative because it's inconvenient, right? Divide both of them by. Can n be a decimal? No, right? You can't have 3.5 sided polygon, right? You can't have that. It's either whole number, it's all or nothing. So this is as if you divide that, you have 19 sides. Do not try trial and error. You have to show me, because some students just plug in until they find it, right? And then they tell me, hey, n is equal to 19. I'm so smart, right? It's like, no, you got to show me the steps. Okay, here we go. Do you remember your textbook? Yeah, you remember what that looks like? Shake the dust off and get it working. So the answers are at the back. So if this 10 to 11. Oh, wait. Yeah, 10 to 11. Thank you very much.